So, this is actually going to be a discussion of a topic that would fall in the curriculum under Unit 5. We tuck this and one more idea into Unit 4 because, as you see with Unit 5B, when we're talking about trend lines, it's a linear equation that we're finding. So, it kind of fits better with Unit 4, just to let you know. So, anyway, today's objective is to go back to graphing real world cases, and we're going to be graphing bivariate data using what is called the scatter plot. We're also going to draw trend lines in and understand what the word correlation means. I think this is one of the most important graphs that we do. You could think about bivariate means two things that are varying. I mean, that's what bivariate means. And in any scientist that's studying a population of animals, as time goes by, what's the population doing of the African elephant, for example? Or we could do data like we could measure somebody's height. We could measure the circumference of their head. One of the axes would be their height, one would be their circumference of their head, and we could plot everybody. And then we look to see, is there a trend? Can we make predictions based on the data we're gathering, basically? So today we're going to talk about making a scatter plot. So first of all, scatter plot displays two, that's where the bi comes from, data on the same graph. Like line graphs, scatter plots are useful for making predictions because they show trends in data, what's going to happen in the future. So when you hear people discussing, for instance, temperature change and what's going to happen in 50 years, or like I said before, a certain population of animals or humans or whatever, they're basically gathering data over time and then predicting using a scatter plot and a trend line what could happen in the future. So basically, if the points on the scatter plot come close to lying on a straight line, the two sets are related, and the word we use in math is that they are correlated. So I'm going to give you three examples so you plot your data and see how we can draw a line through the center of the data and it has a positive slope. I guess we could think of it that way. That would be a positive correlation. If we plot our data and it goes down to the right, it would be a negative correlation, a negative connection. And if it's scattered, truly scattered, i.e. scatter plot, but if it was truly scattered, it would be no correlation. Now, the term trend line can also be replaced with the line of best fit. And if you can put in a line that best fits into the data, that will show that there is a correlation, there is a connection, there is a relationship between those two sets of data. So let's get away from the math theory and talk about it like real world examples. So again, a correlation is the trend between two sets of data. So a positive correlation in general, as one data set increases, so does the other. So an example would be the more you study, your test grade should go up. So both of your data sets are going up, or think of it the other way around, the less you study, the lower your test grade. So basically a positive correlation, both sets of data are going in the same direction, either both up or both down, and that will make a positive slope line. A negative correlation, as one data set goes up, the other one goes down, decreases. So for instance, this is a really good example. If you raise the price on an item in a store, less will be sold. So the price goes up and the amount goes down. And if it goes on sale, the price goes down, you will sell more. So that's an example of a negative correlation where your two data sets are going in opposite directions. And finally, let's give an example of a no correlation where there's just no relationship, like how long your hair is versus the time it would take you to run a mile. So, longer hair doesn't mean you take longer. Shorter hair doesn't mean, you would run it faster. So let's just think about that as we go through here, and let's do some examples. So what is underneath the yellow box is either, positive correlation, negative correlation, or no correlation. So days with rain in a given month versus days without. So if there are 10 days of rain, how many would there be in, say, a 30-day month that aren't? And what if there were 20 days of rain? How many would there be without? Think about that for a second. Okay, and did you realize that it would be a negative correlation? The more days of rain in the month, the less days in that month without rain. See, they're going in opposite direction. All right, how about height? The height versus your free throw shooting percentage in basketball. So think about the taller you are, what happens there? And actually, there is no correlation. We often think that height has an advantage in basketball, and that would be true when you're up against somebody, underneath the basket. However, when you are throwing a free throw and nobody's standing in front of you, actually, sometimes it is often the shortest person on the court, the point guard, who has the best free throw shooting, but that doesn't mean that we can't have tall people doing it too. So there's really no correlation there. How about the number of pets that you have versus the amount spent on pet food? That one should be easy, right? The more pets you got, the more money you're spending, people. So they're both going in the same direction. The more you have, the more you spend. The less you have, the less you spend. That would be a positive correlation. The years that you spend in school, high school diploma versus a college degree versus a master's degree versus a PhD versus your annual income. It is true that the more school you have, the higher the amount of money you make in general, usually. Okay, the temperature outside versus the layers of clothing you wear. Higher the temperature, the less layers. That's a negative correlation. And finally, your shoe size versus the number of friends. Sorry, I couldn't help chuckle on that one. No correlation, right? Just to give you some real world examples. And let's just put that to a graph. So if you look at this top one, notice as X goes up. So as we go to the right on X, Y goes up as well. So they're both going up. Or if you reverse your thinking and you let X come down, Y is coming down, that is a positive correlation. Both data sets are moving in the same direction. And here's two different examples. Let's just drop to the bottom for a second. As X goes up, Y is coming down. So if you plotted this point, it has a higher X but a lower Y than this point. And notice that the trend line, the line that we can draw through the center, which we're going to talk about more in a minute, has a negative slope. Same thing here. And this is just really scattered. I mean, which of these lines goes through the center? This is an example of a no correlation. There's no trend between X and Y on a graph. So we talked about what was going on with words, and we've talked about what's going on the graph. So hopefully you have an idea of what this correlation means in terms of a scatter plot. So correlation strength, we can talk about data being, strongly correlated, perfectly correlated, weakly correlated. So that's kind of what we're going to talk about right here. If your data points that you plot were to perfectly fall on a either positive or negative slope line, like you draw a line, a trend line through, and you hit every point, that's called a perfect correlation. Here's an example. The months since your birthday and the months until. So I'm born in September, and there's been, let's say, October, November, December, January, 4 months since my birthday, and then there will be 8 until. And then when I go up a month, it would be 5 and 7. And those points, if I plotted those, it would be a perfectly straight line, a perfect correlation. So that's an example. It doesn't happen that often in the real world. So what we see more often is something like this. So the stronger the relationship between the two data sets, the closer the points will come to that perfect straight line, and the easier it is to draw a trend line. Remember I said that. So it's easier to draw a trend line on this graph than over here. There's more wiggle room, as we'll talk about in a second. So, which scatter plot shows a stronger correlation? The tighter those points are to that perfect correlation, the stronger the correlation there is, the stronger the relationship. So this would be called a strong positive correlation, and this one would be a weak positive correlation. So let's start talking about doing a scatter plot and then talking about drawing a trend line. And that's kind of what we're going to be doing now. So a line can be drawn through a scatter plot. It's a single line. You don't connect the dots. This isn't a line graph. You're going to draw one line. It's going to be called the trend line, or you can also known as the line of best fit. Okay. So in this particular case, there's temperature on our x-axis and a concentration on the right. And you can see that there's a positive correlation, and it's a strong one. And it's very easy to draw that trend line in the center. When you're drawing that trend line, it needs to go through the center and roughly should have about the same number of points above as below. It can touch the points. It can touch none of the points. It can touch some, so it doesn't have to touch data points, but it needs to run through the center. And again, you don't connect them. So what we're going to do right now is we're going to put in a trend line and, why, what is it for? Okay. So given this data, this is the hours studying, and this is the grade acquired, and you're all sitting there panicking saying, oh my gosh, 11 hours studying. I want you to think more about maybe an older sibling or somebody in college. I know when Jack was taking thermodynamics, the idea of studying 11 hours is not far-fetched for an exam, at that level. So anyway, we're going to make a scatter plot. So we're going to put a good title. We're going to put our labels. Now, the grade depends on the hours of studying. Your hours of study, it's not the other way around. So notice our independent variable is hours studying, and our grade percent is our dependent variable. And then all those good graphing techniques we've talked about, make sure your scale, see, these are going by twos all the way across, and I'm going by 10 percentage points on the way up. There is a break in the graph, which I kind of put below. So, we're not starting at 0 on the Y. So you make your scatter plot by creating all of your scales, and you plot your points. Now what we're going to do is we're going to take our ruler, and it's really better to use a clear ruler. Now, if you don't have one, you actually can use a piece of spaghetti. Obviously not cooked, okay? And you're going to come here. See, now this trend line, if I was to place it here, is too low, and up here it's kind of too high. So I'm looking to get it in the center of the data. This is the most important thing we kind of do, and it's pretty darn close there, okay? See what I did there? And sometimes what I'll do is I'll just trace my finger through the center of the data to give me an idea where to put the ruler or, the piece of spaghetti. Why a piece of spaghetti? Because you need to be able to see the points underneath. So if you have a solid ruler, you can't see them. Now we're going to draw a trend line. Now, the advantage of a trend line is that you can make a prediction. So, given this data, predict the amount of studying required to score a 97, right? So now I've got my trend line. So I'm going to take my ruler, and I'm going to go find 97. That would be 95. So 97 would be maybe right about there, okay? And I draw a horizontal graph. Now I'm going to draw a horizontal line, sorry. Now I'm going to draw down from that point on the trend line, down, and when I come down here, I can find my answer, which in this case would be 12 hours. So to get the 97%, according to my past data, I'm going to need to study 12 hours. And this is kind of what we just did. So that's what a trend line does. It allows you to make predictions into the future about what is going to happen with whatever two sets of data you are looking at. All right, so we're going to do one more together from start to finish. This is actually going to be a scatter plot showing the winning times of the women's 100-meter butterfly swim event at the Summer Olympics. We're going to start in 1968. It goes every 4 years, you'll see, because the Summer Olympics go every 4 years. The Winter Olympics, just to let you know, at one point, were on the same years as the Summer Olympics, and then they didn't like that, so they did make the Winter Olympics at one point go 2 years to get them off from the Summer Olympics. But anyway, from 1968 to 2008, and we're going to predict to 2012, which is no longer a prediction. We're past that, but I'm doing this on purpose because I can go out and verify what our result is by seeing what happened in 2012. So when we go to make this graph, just like we've talked about before, the first thing we want to do is put on a good title. So winning times for the, women's 100-meter butterfly. The next thing we need to do is decide who is our X and who is our Y. So, here's one where I often tell you, if time's involved, it's usually the X. I don't say always. Well, look here, it's time on both. So which one is going to be our X? Does the year change based on what the swim event's time was? Or does the time change based on the year, right? So that sounds kind of silly, but the race's time depends on the year. So down here, we're going to put our year, and over here, we're going to put our winning time in seconds. Now we need to make scales. So, definitely not going to start at 0. I'm going to put a break in the graph because otherwise all my data is going to be sitting way up in here rather than centered. You want your data centered in the graph. And I'm also going to put a break in both directions so that I can center that data. So here is a possible good scale going every 4 years. And again, there will be a break here. You'll see, I'll draw it in the next slide. And then, I'm going to go by 5s. I got to make sure I get all these numbers in. And I want some room to show a trend in either direction. So that's why I didn't start exactly. I left some space below and above. And now I'm going to plot my points. And I plot my points. There they are. So, 68 was about 66. 72 was about 63. And I plot all the points, and then I get that ruler. This one's, it is a negative correlation. It's a little tough to get that line in. To be honest, it's easier down this end, a little bit tougher up here, but that looks like a good placement. Now, remember, we want to make a prediction. So we want to go out to 2012 and figure out what we think is going to happen based on past results. Oh, by the way, if you look over here, the flags are telling you who won. Australia, Japan. You might not recognize this flag. It looks like Germany's flag, and you would be correct. But at that time, it was West Germany. Germany was divided into 2. America, obviously, China, France, Australia again. So those are, the winning countries of this event. Okay, so here now is where, I'm going to take and I'm going to draw. This time I would have put my vertical line up to hit my trend line and then horizontal over. And so that's what I'm thinking the winning time is going to be, which looks to be about 56 seconds. So now I went out and looked on Google to see how close we were. And it was actually 55.98 seconds. US won in 2012. Dana Balmer won this event, and we were pretty close with our prediction. You could ask yourself the question, will this trend go on forever? Or will this linear relationship somehow flatten out and become more of what we've talked to as a piecewise function? At some point, this portion breaks down. Right now, this trend line looks to be, doing a good job predicting, but what will happen in the future? We can't have somebody swimming this race in negative seconds, or even more so, how fast will the fastest person ever go? Kind of an interesting question. So today we talked about scatter plots. I view it as one of, if not the most important graph that's used in the real world, as we've seen a couple different examples here, to make predictions. So anytime you hear somebody kind of talking about what's going to happen in, 2050, or what's going to happen in 60 years or something like that, this is the kind of analysis that they're doing. Now, they're going to do it with technology, which we will learn down the road, but right now we're kind of doing it by hand to kind of understand how this is working. So we're going to start today simply by drawing our own scatter plots, good title, good labels, good scales, plot your points, and then put that trend line in, center of the data, as many points as above as below-ish as you can. And the next video we'll talk about another way to make the predictions way out past the graph. And that involves, of course, writing the equation of a line. Guys, scatter plots, that's what we're doing today. I hope you all have a great day.